Yeah. Well, it should be live. I gotta turn this fan off. Yeah, it's very hot in here. Yeah, I don't know what's with the. I gotta fix the settings on the camera. I don't know what microphone's working. And what else? Yeah, I haven't done this in a while. So, expecting a guest. So that should be good. And hopefully the link can ship and work properly. Oh, shit. It took me forever. I had to do this in Internet Explorer. I mean, it doesn't even work on that stupid Edge thing. I don't know why they have something. I mean, why they have a new web browser and it doesn't work. What's the point of that? All right, microphone is down here, so I better have this ready in case I need it. Cord from here. Not so much cords. The whole computer. Yes, I have to figure out what. Yeah, this microphone's on. Okay, so I will have to use this one. And then I can see about fixing the camera, maybe, but maybe I won't mess with it. So just be asking for trouble. So it'll have to be crap video and such, and so forth and whatnot. So anyway, it's the guy from DissidentScience, David D. Hilster, and we're similar enough in age, and I think he's friendly enough a kind of person that we should be able to get along without too much trouble. And we have the common interest of regular sciences. Yeah, I'm more and more getting up to speed of everything's corrupt and it's full of liars, because it can be this bad just by accident. I mean, it's just so many things are so glaring. The omissions are just so obvious. The evidence is so shabby for such confidence that's portrayed, and it's just this droning that you must believe in the wave-o-matics. Wave-o-matics. It's, the future, the past, and the everything. Let's see, did my email send? Yeah, who knows? I better check my inbox and see. Well, that won't tell you much. Check the sent box. Yeah, link. Okay, I did send it. Oh, I hate these. I just hate having to do this crap on different computers. And this stupid Windows 10 is such a piece of shit. I just hate it. Regarding the link. Okay, downloading now. Good. Okay, so we should be getting here eventually. Hopefully he's not using Firefox. I should have given him more fair warning. Firefox won't work. They broke it. Firefox is getting lamer and lamer. I'm getting kind of to the point where I sort of understand that there'll be a point where I just have to bite the bullet and say, fuck it. They don't want to be a web browser. This whole thing where they don't even bother, they're not going to support Windows XP is just bullshit. So anyway, I should stay on this physics subject mostly, partially. But this David guy's also a programmer, so that makes things interesting also. Well, also a programmer, and that he does it probably better than, professionally and such in some manner or other. But, the whole point is that professional doesn't mean what it used to, I guess. And professional scientist doesn't really mean anything. Because they don't, I keep using Newton as an example, but Newton was a nutter. I mean, he believed in all kinds of wacky shit, angels and all kinds of shit, but he didn't shove any of that crap into his physics. And he didn't do a lot of speculating about things he had no idea. He didn't, no, that's not true. He would speculate, but he wouldn't publish that as science. He would publish that as Newton's speculation. And so, I mean, he speculated that perhaps light is a particle that can be moved by gravity. And so he wasn't obnoxious to that idea. Where I think I would have concluded that it wasn't, just because it was first the constant speed thing. Just, well, he didn't know that. so whoops, sorry, Newton. Yeah, there's a lot of things he didn't know about light. But I guess just the fact that it, you can't bend it with magnetism or anything else. Why would gravity be able to bend it? Just doesn't make too much sense. But that's, see, he didn't have the advantage or disadvantage of being brainwashed the way we are, by this, all this, the crap that we're fed from the beginning, where they just start talking electromagnetic waves, and you're like, why Newton didn't have that prejudice, so he didn't have to think about, what do you mean it's waving this way and it's going this way through these whatever fieldy things, blah blah. So I mean, he never had a confused view of this thing. He just saw it as a thing, and it kind of seemed like it was clumpy, tawny, and so it would make sense that he would think of it in a sense like a little planet, and it would be affected by these universal forces like gravity. But again, he didn't say that was a fact. He didn't have any facts, so he didn't say it. And it's just, that's the thing about scientists now. They just, somebody says something, and they do what I have to admit, often in philosophy, I just make it up as I go along. You just think on it for 5 minutes and you say, oh yeah, that's a good enough answer. And, it sort of becomes your truth, or a part of the truth, until some better theory comes along. And it's sort of like, my 5-minute guesses are usually better than people's, hours of thinking, my experience anyway. Look, frankly, people are mostly wrong and I'm mostly right. And this is going to be another case where I'm mostly right and they're mostly wrong. Just as it's always been, it will always be. And I'll be demonstrated to be right in the end. But anyway, but yeah, it's just this idea. You can just see what they've done, that they've just stitched together, a bunch of suppose, and some guy makes a suppose and everybody says, oh yeah, that's sort of an interesting suppose. And it just becomes the truth, even though there's not one little piece of hard evidence that really indicates it. And there's only a bunch of little vaguey, sloppy evidence. And the Eddington experiment was really such an example, because even Einstein got very humble late in life. And I saw a recent quote where he basically said, I'm not at all comfortable with what I've done, my life's work. And I even question whether I may have been on the wrong track entirely. And that's a very humble thing to say. But at the time, he wasn't too humble. When Eddington found his proof, he wasn't very humble. And he should have been cautious and said, hey, look, I'm a scientist. I understand exactly how difficult it is to find this tiny difference that Eddington found. And, such a tiny, clumsy humans doing such fine work under such difficult conditions, eclipses, plus you're using 2 images from very different points in space and blah, 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 and trying to make these comparisons. Yeah, it could be that this isn't good evidence, that, it really wasn't proven. And they just didn't do that. And they should have recognized that they were talking way past the quality of the experiment itself. It's just not an easy enough experiment, especially back then, for such a bold declaration of, we have now established this as a truth. And all the galactic images are just crap. I mean, they have so many flaws, just consistency flaws. They're not consistent with the laws of gravity and the speed of light or anything. They violate the rules all over. There's David, it appears. Let's see if he can make a sound. I don't think I have to activate him or anything. Speakers, I should have speakers on. Sure, I should. So if he's talking, I should eventually, well, his camera's not on yet, so we'll have to see if his camera comes on. Let's see, the chat thing. I never look in the chat. Maybe somebody's chatting something. Oh, that's right. You have to open the regular video to see any chat. I didn't do that. Figure something's going to blow up if I mess with it too much, so I'm a little worried about doing anything. Yeah, it's weird. The Internet Explorer, this is the only window that's open. It's the Hangout window. Usually, maybe I can do it in the DraftScience. I mean, maybe I can do it in Firefox. Well, that's dangerous. I don't want to. Well, fuck it. I'll do it anyway. I live for danger, right? I probably don't, because I'm a bit of a pussy. Let's see. I can't even find my regular settings here. Creator Studio. So if you're using Firefox, David, you're probably not going to get anywhere. Yeah, you have to use that stupid Chrome piece of crap. Or I'm using Edge, but you have to use it in the old form. At least I had to. The Internet Explorer form. Now, let me see if my live streaming window will open. Probably doesn't like me opening the same account in 2 different browsers. Probably a rule against that, Gary. Let's see. Make sure. Oh, there's David. He's getting closer. I see him. Now let's see if we can get some voice out of him. Say something, David. Ah, shit. Let's see. Yeah, sign language. Okay. Yeah, let's do it first. Let's do a hangout in sign language. It'd be really cool. Except I don't know any. Well, I know a couple. Yeah, I know this one, and I know a few signs, but yeah, they're not useful ones. Let's see if there's some way to get audio. So there's a little wheelie thing at the top of your settings somewhere there, and you should be able to make sure you have a mic that's on. And then we'll see how we go. I had a hell of a time. I had to, I really had a hard time getting into my own room today. I started like 20 minutes early, and it took me all this time just to get my own browser to work. Still can't hear you. Let's see. What can we, something, I just don't know if there's something I have to do, but I don't think there is. You don't appear to be muted, but it doesn't give me any, like, Let's see what it says. Hide from broadcast. Don't want to do that. That sounds unpleasant. Eject. No, there's no bad choices. I won't select any of those bad choices. I refuse to play Google's game. So let's see. I don't think like I said, if I was had to unmute you, I would have to unmute you. So unless your microphone. Yeah, got to find the camera. You got to find a separate mic or something like that. This really don't make this technology as easy as it could be. It's all nice, pretty icons, but nothing's coherent. But yeah, I should find the chat. So let me go back to looking for my Netscape. What we're doing? I mean, my Netscape. Yeah, Firefox. And let's see if I can find the. All right, this one is on live stream offline. Why does that say offline for? That's weird. Offline. I don't want to do offline live streams. No, that doesn't sound good. Let's see, DraftScience live stream. Streaming now. Live streaming. I should have a link in here. Why is it saying offline? Oh, that's right, because I'm not on Google. That's why. You dumb so forther. Let's see, why does it say that? Offline. Well, I'm just confusing myself, which isn't that unusual. So what do I need to do? I need to get to my channel Yeah, I can't figure out how to get there without making a mess. Won't be in the videos. Why are they posting this stupid password thing? But yeah, I need to get to my live video somehow. So I need to see my subscriber. Ooh, maybe it's on the Google thing. Anyway, I'll go back to see if David's still there. Still working on it? Or, okay, thumbing up. Okay. It hasn't shown up in my subscriptions yet. Oh, that's the way to do it, Gary. Just do it on the other computer. You dumb bastard. I should be able to do it anyway. So if I open this video in a different tab, I should be able to see the stupid chat if I can actually find. Oh, there it is, live now, DraftScience. All right, I'll click on that one. And then I have to mute it. Well, it won't play anyway in my XP browser. So anyway, but I should be able to see the chat. Got it. Ah, there you are, chatters. Sorry, I haven't been reading any of your crap. Let's see. Well, at least it's working. Okay, good. I'm working anyway. Video is fine. Link share. No, I'm not sharing any links. Not a room for you peasants. It's a room for professionals. All right, David, testing. Say something. Yeah, okay. That wasn't the right thing to say. Still trying. All right. Got the technology out. So it does, you know, like I said, I was panicking. I was saying, oh, I'm not going to make it. And finally things started working. So anyway, mute yourself, then keep trying to connect the audio. Well, I don't see how muting himself would do that. I'm at the hospital with PhD student, LOL. Yeah, you got to make sure you haven't muted yourself accidentally. So if you check on the little arrow on your icon or something like that, you might be able to tell if that's the case. But your video disappeared. No, it's just, sorry, that's fine. So you have to make sure you're not muted. And then check your settings to see that your mic is identified properly. You might want to try too, if you think something's missing, you might want to try just reloading. You know, hit the reload button and just come back into the room again. You know, in case it just, you know, if everything looks okay and it's still not working, maybe it just needs to reset the software. So, let's see, where were I? Ah, there he is again. Let's see. No sound. Damn. Let's see. Maybe what else could we do? I got a lot of string. Maybe I could roll a tin can down the highway and maybe get to Florida. Nah, I think he's in Florida. No. Let's see. I'll click on your video, then I can see it better anyway. There. All right. So let's see. Any other suggestions from the peanut gallery? Yeah. LOL. Good luck. Have a good day and all. I'll catch up on the flip side. Oh dear. It sounds like something Bart Simpson would say or something. Let's see. None of the 3 mics are working. Ah, cool. You don't have one on your webcam, right? Oh, it's a laptop? You know, sometimes you just go with the webcam mic, and I have two mics. You know, they should work. I guess it's your sound card has to be identifying them. So maybe it's, you know, the sound card isn't recognizing the mic. My audio seems to sees and hears the mic. Okay. So, and then when you go to that wheelie thing on the top of the window, you know, on the window here, there's the settings button. Now on the settings button, it should identify your default microphone and the camera and your speakers. And you have to make sure that the sound card or whatever's running your microphone is identified as your default mic. It might be defaulting to your phone or something. I mean, it does stupid things sometimes. The default isn't the right, you know, sound card. So, still working on it. And it's a technology problem. It should be overcomable. Enough practice. So let's see if I can make up them things about David. Let's see. As a young lad, he used to go routinely mountain climbing, walking backwards, because he just said, forget it, I'm not doing this the normal way. I'm going to climb the mountain walking backwards. So he'd climb all the way up the mountain walking backwards. And of course, the liability was you get to the top of the mountain and you trip over the point on the mountain because you're walking backwards. And then he would, you know, often hit his head on many rocks, and it turned him into kind of a cranky person. I will leave and come back in. Yes, try again. Okay. And after that, it was all downhill. Oh, somebody said something here. Hey, Gary, why don't you make a Amazon wish list? No, there's a donate button on my fucking channel. Amazon. What a stupid way to, you know, blah, blah, blah. I wouldn't buy anything from fucking Amazon. It's a fake company. Fucking douchebag has made billions of dollars running a company that's frankly perpetually bankrupt. Let's see. Wow, just buffering. But enjoyed your last video. I don't know what that means. Oh, you deleted it already. Cool. Yeah. So far, so much fun. So anyway, I thought we would talk about such things as, you know, there needs to be a good publishing magazine. You know, like the Medical Association has their Journal of the American Doctor or whatever, and something like that. But you know, physics has all these sloppy journals. You know, Discover Magazine and Science. You know, it's all crap. And yeah, there should be a real disciplined way of, and they should publish things. You know, because now publication isn't like magazine publication. It isn't like they have a shortage of space in the magazine, so they should publish everything. They should just put their editorial rating on top of it, like, we think this is a piece of not, you know, 14 out of, you know, whatever number of editors thought this was an absolute piece of steaming shit. You know, and they don't have to be bigoted about it. Let's see, what other thing can you use as a microphone? I have to think of something else you could plug in. Plug a speaker into the microphone jack and see what happens. Sometimes it works. Let's see, the sound card thing. So so it does. So when you go to the little settings button on top of this window, it actually says says your default microphone is the right microphone. I have 6 mics and Hangouts aren't recognizing any. But all the mics should be running through the same sound card. So when you go to that settings button, does it recognize your sound card? as the default microphone. Because that's the one that's the first one you have to have right, is the YouTube settings, when they have to be recognizing your sound card as the source of the microphone. Let's see, so catalog the system, right. Let's see, right-click volume icon on bottom right of taskbar. Oh, well, I think he knows that. Select recording device to see if the mic is muted. Well, you can tell if it's muted. I mean, it shows muted. Let's see, showing his devices here. Let's see, microphone problem. Okay, here we go. Hangouts. All right, so what browser are you using? Whoa, it's me. Hi. Hey, that's Amendum. What's he doing on this video? This is a DraftScience video. Chrome, you're using Chrome and it's fucking up? Amazing. So what's the error again? I mean, it says it's not recognizing your sound card. I just never, I mean, I've never even heard of an incompatible sound card. Analog NEO, let's see, USB is ready. Let's see, select one, yeah, okay. Microphone is ready. Yeah, so move the default up to one of those ready devices. So yeah, click on one of the ready ones. Figuring out which one is the right one, that's the trick, yeah. Oh, come on, every single one of them? Microphone 4, let's see, that's gotta be some way around that. I wonder why they're identifying them as, let's see. So a Logitech HD Pro webcam doesn't have a built-in audio. Weird. That would really be helpful for that audio. Oh, a laptop again. Yeah, right. Forgot. Let's see. So what else could be the problem? It's recognizing 6 microphones, and yet it has a problem with each one. I don't even know how you plug 6 microphones in. It is a tower. Oh, okay. With 6 sound cards. Let's see. So yeah, but the default would be on the laptop would have a default. So the problem is you don't have a default, one that works. Let's see. Yeah, I guess maybe you have to have too many open now, and so now you should unplug them all and just plug one of them in, like the USB mount, a USB mic if you have a USB mic. So like unplug them all or unload them all, and then just plug in the USB one, and then make sure that Google can recognize, because it shouldn't be calling them microphone 1, microphone 2, microphone 3. Those aren't even proper names for a microphone. I mean, they usually show the device name. At least mine does. I mean, it shows, what the audio device is. It doesn't just call it microphone. At least I don't think it does. Guess I could check. See if mine calls it microphone. Default microphone. Yeah, they calls one is the microphone, which is the high definition audio sound card, and the other one's my webcam. Yeah, so it identifies my microphones properly. Strange. I just said chat. There's messages in the chat. There's never messages in the chat. Strange. Now there's two chats. Chrome is the most popular browser. It's not really popular. It's just that Google's been not promoting it. They're all from David. Okay, I'm working on my mic here. So it's all his comments are in this chat window, and other people's comments are in the other chat window. Let's see. I have 6 mics and Hangouts. Are recognizing any? Chrome. Okay, no laptop. Okay, so this is just his messages. Good. This I know where I can read them in one big bunch. It's a Google Hangout problem. Yeah, I don't think, I mean, it could be, but it just doesn't. I don't, seems to me there's got to be, I mean, Chrome is made by Google, so hell, it's a little hard to imagine they got some glitch like this. No, I don't feel as bad now because I was really panicking. Well, yeah, I should feel bad because you're going through all this irritation now. But it was funny because I was like, oh fuck, this is never gonna work. It used to be the Firefox I could do little tricks and it would still work, and so none of the tricks work anymore. So good to know for future reference. I just really resist putting Chrome on my computer. I just hate Google. And they're part of my technology conspiracy theory. No luck. Trying another browser. I can try another computer. Yeah, well, you can also, I mean, they have an app, but I've never found the app to work very well. But that's, I have a cheap tablet, so it might work well on a very smart phone or something. But you just have to transfer that link to those devices, to some other device. But yeah, it's strange. I mean, it really, it's a problem I haven't seen before. I've done live rooms quite a bit, and it's strange. Yeah, there's something on there. Let's see what happens. You might not be able to use the same account. You have to sign in with a different account because you're still live in this. I don't know that for sure either. I think people have been on the same account with more than one open window. It'd be cool if you got the audio in one of windows and the video in the other window. That'd be pretty funny. Let's see. Should I major in computer science and joint program?
Hello.
There you are.
I'm off. I'm going to get off the browser.
Yeah. Okay. I'll click.
Hold on.
Click on your new window.
Let me get I'm going to have to get headphones for the my.
You have a little feedback.
No, it's my phone here. So hold on.
Oh, yeah, you can't hear the phone.
I'm on my iPhone. Hold on.
Yeah, it's no problem. Good to hear you.
Get my headphones so I can hear right and communicate right. Hold on. Yeah, I'm a computer software guy, and I did some Googling it while I was trying, and it's definitely a Hangout problem. I am on Windows 10 Professional, and that can have a problem. Windows 10 is now trying to usurp other browsers, and in the doing so, they're trying to say how theirs is much better. In fact, so it could be. So the problem was it not recognizing the Google Hangout in Chrome browser was not recognizing any of the microphones. So
Yeah, well, like I said, I
bad.
had a nightmare getting the room open. So first, the Firefox totally failed, and then I opened Edge, and Edge couldn't open it. And then finally, Edge gave me the option to go to an older version of Internet Explorer. I said, "Oh, okay, yeah, do that." You know, it's just kind of funny. So it's in, you know, I didn't know Edge did this, but Edge is actually two different browsers. So Edge is
Yeah.
open and Internet Explorer is open. So it's just kind of funny, but it worked. So I can't complain. So at least it worked.
Well, here I am.
Yeah. So good to see you, David. David from Dissident Science. So the YouTube channel, and then DissidentScience.com, the website, and philosophy something or other.
Natural philosophy.
Yeah, that is.
Yeah.
.org. .org.
Yes.
Right? Okay.
Natural philosophy.
And so yeah, well, he's sort of, I'll paraphrase, you know, you're sort of a guy trying to organize dissident folks, you know, thinkers, into maybe some sort of collective strength where, you know, you're some sort of competition for the standard droney talking head pop culture media thing. So it's almost like the idea of news organizations that are independent and news organizations that aren't, or something like that, and that this is the alternative to the corporate controlled, or, you know, book selling people, you know, that kind of idea. You know, they're just obsessed with, you know, pushing their model of reality. So is that
yeah, that's pretty much it. I have been involved with scientists, serious scientists outside the mainstream. This isn't like New Age or New Wave or Tesla people. These are real scientists for the last couple decades who have been working outside the mainstream, because we have almost 3,000 people cataloged in our system. And I'm right now president of our organization that started in 1993, but I've sort of brought it into the modern age. But we have all these people are professors, almost 20% of the 2,000, almost 3,000 people we have listed in our database are PhDs. Many from, in fact, our chief scientist, she's from MIT, and she's a physicist and a mathematician. The thing is if you really take the time to look at these crazy things that, for instance, relativity predicts or quantum mechanics predicts, and you actually go and start to look at those seriously, you start to see a lot of problems. In fact, we have people who have found these problems, hundreds of them around the world in the last couple decades. And we just started organizing ourselves because we started to look at these problems, and mainstream science has some real problems. This is not something that came about because someone came up with some idea and I've got this new model for the universe. It really came about when we questioned things like, well, if mass increases as you get closer to the speed of light, why? No one tells you why. They say that's just the way the world works. And when you start to investigate, like all these scientists that we hang out together, when you start to investigate it, you start to realize, and in fact, 10 years ago, I started and I made a documentary film that took me 8 years. I lived in LA, had some pretty good editors. And I actually got a Stanford Linear Accelerator particle experimental person. He wasn't a theoretical physicist, but he worked at the Stanford Linear Accelerator. And he basically said, no, we don't observe mass increase. So why is it that our universities all around on the globe tell about how Einstein's special relativity, for instance, has mass increase when indeed it's not even observed in particle accelerators? So these are the kinds of things that I think I would parallel it. And I got my idea to do this channel from my friends because I'm a progressive. I'm a big progressive. I've voted for Bernie Sanders and Jill Stein. And I saw that people were starting to realize, oh, what the mass media tells us about the truth isn't really the truth. And that kind of gave me the idea that, hey, we have the same voice, but it's in science. So when you get people saying, for instance, GPS is a perfect example of how general relativity uses. In fact, if you go to Ripley's Believe It or Not, they have one that says, if GPS didn't use relativity, our cars would be miles off. This is a complete lie. In fact, we have one of our members who has over 30 patents in GPS who basically says the following: GPS shows you the flaws in relativity. In fact, a very interesting thing for your, this isn't real technical, but it's really interesting maybe for your listeners, is NASA has been asking somebody, some scientist somewhere, to explain a 0.56 picosecond difference in their GPS. When they're measuring stuff, it's off by 0.56 picoseconds, which is really, really small. Well, Ron Hatch, who is one of the members of our group, he wrote NASA, and he gave them a real hot potato. And what is that? He says, I know the answer to that. And that is, you have to add the speed of, you have to use the speed of light plus the speed of the satellite to get your answers correct. This is complete violation of relativity. You can't go faster than the speed of light.
Well,
you can't measure. You can't do that.
Yeah. So I agree with you that they take Einstein too literally, let's say. Okay, in the sense that I would argue that there's certain simplicity what Einstein's saying, and he's certainly right about some of it, in the sense that Newton's equations were too simple, because I would argue that, say, gravity, for example, is inductive, like it is the same way you transfer magnetism into electricity. There's an induction that takes place, and that process is not accounted for by Newton, and that's what makes the difference in the precession of Mercury. But anyway, but the rest of it, like the time dilation thing, is, yes, Einstein's saying he's saying, yes, that happens, but he's saying it for the wrong reason. You know what I'm saying? So they're not accounting for it for the right reason, but it does happen. But I mean, I certainly wouldn't agree that photons go faster than the speed of light. I would say I'm quite certain that they don't, that the constant is a valid constant, because there's so many paradoxes created if you allow photons to move faster than the speed of light. I mean, it basically, it cracks the universe. I mean, you just can't.
Well, it cracks their models. One thing you have to be really careful about, and one of the things that we do, and I've learned over the 25 years of hanging out with these brilliant minds, you have to be very careful, because when you say it cracks the universe, it cracks their models of the universe, which blow up at the speed of C. Now, that has been corrected in numerous ways. In fact, my father and I have a model that we've been working on for 2 years that doesn't have those problems. So you don't crack anything. It's we see that there's.
How does time have continuity with by allowing photons to move faster than the speed of light?
Well, you've got your. Let's take a look at your statement. You're talking about photons, okay? Now, there's a problem in the standard model where they don't know if it's a particle or it's a ray.
I would agree with you. It's a particle, right? You're a particle guy. I'm a particle guy, right? So my theory is also all particles. I'm just saying that time is a function, not a dimension, in my opinion. So time is just a function, and everything has to obey that function. That function is the one universal function. Okay, it's the speed, the consistency of the speed of light. And if you basically make something go faster than light, you basically are time traveling. You are moving something into the past.
Well, I mean, if you look at it, if you want to take some of our really good scientists in our group, for instance, Glenn Borkert, and there are a number of other scientists and even ourselves, time is a measurement of movement. Time is movement. And if you don't have movement, time is a concept that we may have made up so that we can measure movement. We can measure where one thing is and going to another. If we call time a thing, which you really can't, time is a concept. There's some things that are hard for people to understand. One is energy is a concept. It is not a thing. You can't give me 3 energies and put it in my hand. You can't give me 3 times and put it in my hand. That's one of the reasons space-time is such an absurd concept, because you're putting together space, which is the actual absence of everything. That's why we have I've got a master's in linguistics. One of the things I worry about is what people use and how they use them. But space is nothing. It's where mass exists.
Supposed to be.
Mass,
it's supposed to be.
Yeah, mass is in space, and it goes through space, and we use time to measure movement. That's what we've done. It's a concept. The problem is if we think that time is actually something, it's not. We do say if you want to look at what we call assumptions, that you have space and you have moving mass. In our model, that's all we have. Electromagnetic fields, magnetic fields, photons. Actually, we have our model is a particle model, but gravity and light are the same particle. The only difference between gravity and light is that gravity comes in as a shower, like your shower just turned on full. Light comes in waves, so it's the same particle. It's just coming in waves, like your shower turned on.
Well,
But again, just the only thing I want to impress upon you is that time is not something that is there. It's not a thing in the universe. What is in the universe that is there is movement. We use time and distance and space to measure those things. So distance, time, space, all the those energy and time, not real. They're concepts that are very useful.
I guess I would argue that all the forces, though, are running at this same time interval. So I'm just saying that all of these particles are the same particle, in my opinion. Also, okay, I mean, a photon is just a graviton at a frequency. So you apply a frequency.
Well, yeah. I don't know what do you mean about, but it's a frequency. What's a frequency?
It's like bullets shot at a frequency. So if I can shoot bullets every 1 second, I can shoot bullets every 5 seconds.
Right, okay. Right. Yeah, that's something my dad, yeah, and he that's the thing that actually solves the wave particle duality, which my father in June of 2015 stunningly showed me this, and I just went nuts because he didn't even know what he had found out. And that's again, I think one of the problems is that when I see, for instance, New Agers or people from Tesla, they're good people. These are good people compared to our group, for instance. They're going to talk a lot of words. They're going to call space, time, and warping, and energy, and even particle physicists talk about this. They don't observe, for instance, mass increase, but they say, oh, but it has an increase in an extra increase in momentum. That's why we have to use the relativistic equations. But they never tell you what the momentum. How can you have an increase in a momentum that's beyond Newtonian, which they say that exists, yet they have no mechanism for it? They have none.
Well, it's all in what they qualify something at. So I would make the argument that the problem with this duality is also that there's a conflict between understanding what a force is, and I would consider photons in the category of a force, and matter. So moving matter a speed is a lot different than force is moving at a speed. So the forces are all obligated, in my opinion, to move the speed of light, and you can't add anything to their speed. So in a sense, momentum becomes kind of relevant, but in another sense, it's not relevant, because it's like, say, the difference between blue light and red light. I would argue that their momentum is exactly the same, and the only thing you're changing is the fact that one has more of an effect on an electron. It's the tipping point argument. If you shoot bullets at a certain speed, it'll knock a tower over. You shoot them too slow, it won't knock it over. And so it has nothing to do with the real energy. It just has to do with the fact that blue light, in the same distance of space, in the same measurement of time, there'll be more tons because they're closer together.
Yeah, no, it's a frequency. Exactly. Here's the biggest problem. And what you're talking about is sort of like a model. Until anyone has a model of all this, they're just blowing smoke. Because, for instance, in our model, the electron, electricity, gravity, and light are all the same particles because they all go at the speed of c more or less. We also have infinite levels because you can't have magical particles. So we have a gravity 1, which is what affects our planets and all that. G1 particles are electrons. They go around the nucleus. Well, what keeps these particles going around are G2 particles at different levels. So the nuclear force is just a level down of gravity of a different. Now that the reason we can say that is we have a model. You just have to have a model. That's what you have to do. Well, people talk without models.
Yeah, I'm just saying I do have a model. So I've already heard your model. So I'm familiar with it. Right. I'm just saying I have a complete model also. I mean, a complete unification. Sure. I define, I can explain why there's time dilation, and I can explain why there's the strong nuclear force. And the difference between our models, like I said, we start off with the same. This is sort of something I wanted to get to. It's like me getting into this was really a slow process, in the sense that I remember being in high school and being told what a photon was, and I just said, bullshit. you know, it made absolutely no sense. That should go away. Yeah, I'll make it go away. You know, it made no sense to me, this model of, you know, waves this way and waves this way in this undefined field. So it's another bent space thing where they just create an ether and they don't want to admit it that's an ether. You know, they're just, you know, playing a game. I don't know why this phone is still ringing. Anyway.
Hi, this is Gary. I can't get to the phone right now, but if you leave your name, number, and a message if you like, I'll get back to you as soon as I can.
No, I'm not going to do that. Anyway, so anyway, so that's where it started. And then the two-slit experiment was where it started, like 7 years ago for me, in arguments with people, because there was these silly explanations, right? Copenhagen, many worlds, all these dopey explanations. They're just made out of magic, just complete magical explanations. And I said, that can't be the right answer. And so then I said, I'm going to go find the answer. So that's really what got me to it. And then once I did that, I started thinking about photons. I said, well, what if they're particles? Okay, let's go hard with particles. And I said, well, what if gravity's a particle? You know, why am I glued to this stupid gravity thing either? And once I did the particle gravity thing, you know, then I fell into magnetism. But the key difference between our two theories is you don't like charge, and I think charge is the whole game. Polarization is what.
But charge, you have to have a reason for movement. What you're doing is what. But Alexander Unsker, you can't just put a plus and a minus and then have things move. That's why we have an infinite force.
I know, but that's not what charge is. Charge is polarization. So
I'm not understand that.
Well, I'm just saying that it's a polarization of a magnet. So let's say the two, you know, you're not familiar with my theory, but my theory says basically that there's two elements, the proton and the electron. They're different color, let's say. So we just use color to represent charge. So one's black and one's red. And the photons in the field, the gravitons, the G1 particles you're talking about, there's two types, red and black. Okay, so what happens with charges is the black ones, let's say the electrons are black. The black ones reflect off of the electron. The red ones go in and leave perpendicularly. Okay?
But see, that's still magical powers. Though.
It's not a magical power. A right turn is not a magical power. But anyway, we're probably not going to get anywhere if we just argue physics.
No, that's okay. No, that's okay. One of the things that I think is interesting, maybe your people, the audience that you have can watch, is to listen to Dr. Unsicker, Dr. Alexander Unsicker, who's a physicist with a PhD in, he's talked with our group several times. He gives lectures and he wrote the book, and it's a really interesting book for your audience if you want to take a look at it. It's called The Higgs Fake. And basically, he says that you have to throw out particle physics since the 1930s at least, because what happens is they're inventing particles with arbitrary attributes that do magical things. Charge is one of those as well. Charge, and for instance, fields, people talk about fields, they're not physical. Charge, it's there's an attraction or some type of attribute. Right. And with the moment you do that, you would have to explain.
What do you believe in polarized light?
Well, we have a model for light. We know what polarized means. So polarization is actually like what we see, which is they're just particles coming in vertical groups. They're coming all together at the speed of C in groups, in vertical or horizontal, whatever angled groups.
Well, an angle. So if I gave the analogy, this might be an agreeable analogy. The analogy would be the photons are like a frisbee, and a polarizing filter would be like jail bars. And so if you throw the frisbee horizontal to the jail bars, it won't go through. But if you throw it vertical to the jail bars, it will go through. Would that be an acceptable analogy?
Yes, but my question is, what's the physicality of what polarization is? What are
It's just the shape of the photon. Let's say it's a photon.
No, I'm talking about you're talking about polarization. What are there big screens or bars everywhere in the universe, some lattice or something?
No, I'm talking about the only way you can detect polarization is by orienting a filter. You can only detect a filter.
Right, I understand that. But the
polarization is arbitrary until you filter for it.
But so in your model with the polarization, I'm just again, I'm trying to understand what is the thing that makes things polarized? Not the light itself, but what is the thing?
I just gave the analogy. The frisbee.
No, I know the analogy, but I'm saying
there's no jail bars in space. Okay, the jail bars can be a filter. Okay, like whether it's a fog or whether it's made out of some other material thing, but it has to be able to create the filter. Like say the reflection of glass. Okay, if you reflect light off glass at the Brewster angle, all the light leaves at one specific polarization. So it all ends up being frisbees going the same way.
No, I understand. I understand very well polarization. My question to you, and I'm trying to understand the model. What is the thing that's polarizing to make the two particles do what they do? The polarization part, not the things that are being polarized.
I don't understand the question. There's only only a orientation in geometry. It's a geometric orientation. Polarization
just means what physicality is the thing that creates that?
It doesn't have to. It's made by the universe. Photons have a shape. Photons are shaped.
No, I understand that, but I'm saying that if it's polarized, that means a particle's traveling through something that makes it polarized. I'm trying to find out.
It doesn't travel through anything. The filter, okay, allows it to pass or doesn't allow it to pass.
But what's the filter?
The filter's like jail bars, a polarizing filter.
Right, but what's the jail part in your model? What are the jail bars?
The jail bars are the polarizing filter. That's how they make them. The polarizing filter
so you have in your model
molecules lined up in bars. What? Sorry, didn't hear you.
In your model, again, I'm not arguing at all, actually. I'm trying to understand.
I understand, but I don't understand the question.
What I'm not understanding when you say filter or bars, I'm wanting to know what those are, not the particles themselves.
Polarization is only recognized by another material object, just like magnetism is only recognized by certain compounds, right? It has to be iron, or it has to be a ferrous, or it has to be another magnet. Okay, it's most strongly recognized by another magnet. So magnetism isn't, it's a feature of something, but it's a feature that the thing has to be configured to see. So you can't see polarization if there's no bars. If there's bars, then you'll see the polarization.
No, again, I understand that, and I understand. What I'm asking you though is, what's the physicality of the bars part? That's what I'm asking.
The physicality of the bars is that in the case of a polarized sunglasses, it's molecules in straight lines.
But I'm talking about you're saying that polarization, you have, like, would you say an electron and a proton that different colors or something like that, or
that? Well, I was getting to that point, that polarization, charge, okay, and then you could that's the connection between magnetism and electricity. It's all one thing, okay? Electricity isn't a force, it's a consequence, okay? That's electrons moving functionally. And the real mechanism is magnetism. Magnetism is what's pushing the electrons. So it's always magnetism. Magnetism holds the atoms together, and the magnetism is in the form of these filters. Okay, so if you just recognize, if you give my analogy with the light and hitting the jail bars, my argument is, if the frisbee bounces off the jail bars are moved, right? They absorb the force. If the frisbee goes through the jail bars, the force isn't absorbed. And so that's where the difference is, and that's why you have these two polarizations that create an effect. So the argument is, when photons bounce back and forth between two electrons, okay, they can't go through. So they just, as I move the two electrons closer, the little tons bouncing faster and faster and faster. So it's even more impacts. So it's imparting more and more energy. So the more you close the two electrons closer to each other, you keep creating more and more pressure. And the proton and the electron, when they're opposed to each other, the argument is the frisbees are going exactly the opposite way. So all the frisbees the electron's throwing are going right through the bars, and all the electrons the proton is throwing are going right through the electron's bars, because they're the opposite direction. So all the pressure goes away, and the two particles are forced by the G1 particles, in your language, are forced together. So polarization is the key factor for mitigating, for both magnifying the force, the strength of the repulsion, and then the attractive force is merely the consequence of eliminating the internal pressure, so the external pressure forces them together. So there is no true attraction, there's just an absence of repulsion.
Yeah, again, I understand. Again, I'm just trying to think, okay, so you have space and the universe filled with a polarizing filter. Is that what you're saying?
No, the universe isn't full of a polarizing. There's only the electrons and the protons are the polarizing filters. They do all the polarizing filtering work.
But wait a minute, but you said okay, again, I'm just confused. I'm not here arguing. I'm trying to.
I was using light as an example of how polarization works.
But you're saying that the particles like are frisbees. But you're saying that if those frisbees are the bars, I'm mixed up. You said at one point you're saying the bars.
They're not the bars. The frisbees are the force. The bars are the matter. Matter has bars. Frisbees are just quanta. They're the G1 particles. They're the fundamental particles.
Well, yeah, I think the easy way to do this is not to call them G1 particles, because that's a different model.
I was trying to use your language to make it applicable to your model, because your model uses particles to simulate gravity and to also create radio waves. So you're using the same particle for those two functions.
No, the difference is that we have another level down, which are G2 particles, and then we have another level down, which is G3 on an infinitum. And those things all push each other. That's how, for instance, G1 stays in orbit around a nucleon, just like the reason G1 particles in a cloud will keep the Earth going around the moon going around the Earth. And the G2 particles is what keeps G1 particles going around nucleons. So it's all the same mechanism, all the way up and all the way down. But that's in ours. But in yours, I'm understanding there are two.
My argument is the first force, okay, is the nuclear force created when these frisbees, interact between electrons and protons. That force, okay, of attraction and repulsion created by the frisbees going through or the frisbees hitting, that force creates all the other forces. So gravity is a consequence of that force. Magnetism is a consequence of channeling that force. Everything is a consequence of that.
What's the frisbees are a different type of particle, or
they're a quanta. They're like a photon, not at a frequency. So if you think of photons this way, all right, when they're polarized, so think of a quanton. Let's call it a quanton, right? We'll just make it a generic little particle. It goes the speed of light and it doesn't do anything else. It goes the speed of light in a straight line and it's shaped like a frisbee. Okay. Now, when it's at a frequency, that is when you shoot them like bullets at a frequency, it's called electromagnetic radiation. Okay, so it's on the spectrum of electromagnetic radiation. When they're not at a frequency, but they're all of the same polarization, and you're heading for another polarizing filter, then it's magnetism. All right, and when they're neither of the same polarization or at a frequency, they're gravitons, and they push planets into each other.
Okay, I understand. I guess I'm lost on what is the bars themselves, because I got this little quanta, speed of light, which would be equivalent to what we have as G1 particles. That's true. But the question I have is that they're going through, they're frisbee-like. This mass you're talking about, is the mass itself polarized? Is that what it is?
As I said, the agent of matter is made out of electrons and protons. That's the elements of matter. I would argue the 100 other particles science has made up are some derivative of electrons and protons. That's all there is. There's either things with their bars going one way or their bars going the other way. And I'm not saying the polarization of the quanta is purely in three-dimensional geometry. I'm saying that's why I said red or black. Let's just use it as a color thing, and that way it's absolute. All right, because it might not just be geometry. It might be an actual, like, round versus square peg, round hole versus square hole, and only the round pegs can go in the round holes. Square holes, and only the round pegs can go in the round holes. So the idea is that the proton and the electron are oppositely polarized, which means they only accept pegs. The electron only accepts round pegs. The proton only accepts square pegs, and the other pegs go through them and leave perpendicular.
Okay. So you're saying that there's a physical structure to the electron and the proton, and they have this polarizing effect, whatever that is.
Well, yeah. Well, I explained what the effect is. The effect is
no. I'm not questioning the effect. I understand the effect. What I'm trying to say is where. So I think I'm getting closer to the answer with your model. Is that the particles themselves have a physicality that have a polarization effect, like the electron and the proton.
Right. There's two kinds of quanta, red and black. Yes, they're two physically different I don't, square and round. I don't care. Whatever we use for the definition of a different thing. So one's square, one's round. And then the same is true for the electron and the proton. They filter for round or they filter for square. So that's the thing. So the electron and proton are the polarized matter bits, and the quanta are polarized force bits.
Mm-hmm. Okay, so there's a physicality to, okay. So you have one smaller particle, it's got a shape. You've got two other particles, which you call electron and a proton. They have some type of physical property that causes polarization.
Yeah, I'd say the electrons and the protons are made out of those little quanta, but they're in a different configuration in the sense they're stuck together. So let's say all the force.
And what keeps them stuck together?
The field. Like I said, the constant cosmic background radiation thing, the constant random movement of these quanta.
Okay, the three.
Through the universe.
Okay, so there's a fourth particle.
No, it's the same particles.
Well, because you have the electron, you have the proton. They're made of maybe this other one, which we'll call what'd you call it?
Quanton.
Quanton. So the quantons. But then you now talk about a field. Is the quantons the field?
The quantons are everything. That's all that the universe comes down to. So if you were to say, let's draw it all the way back to the checkerboard that is the universe. The checkerboard is made out of this. So, yes,
so you're saying that the quanton is the ultimate particle?
Yeah, it's in everything. Everything is made of it. Okay, so when they're stuck together, we call them matter bits. Okay, electrons, protons. When there's a bunch of them stuck together and they become a filter. All right, when they become a filter, then they become an electron or a proton. But I'm saying, look, that part's not necessary. I'm just saying that if I can make it go so universal that the whole universe is made out of are these checkers that have this simple property. They all move the speed of light and they have a polarization that's either red or black.
Okay.
I'm just saying I can reduce the whole universe to that one elemental bit. And I would argue that all your matter bits are basically right now, all the quantons are still moving the speed of light inside of you. You're still, it's all active energy. And that's what a nuclear bomb, you're just letting stuff that's already moving the speed of light in circles. You're just letting it loose. I would argue they're squares, but it doesn't really matter.
So you're saying that there is an ultimate particle, is that right?
I'm saying there's a true elemental particle. I don't know if I would ultimate. See, this language is always so tricky, right? Because you use the word.
Well, charge. No, I mean the ultimate particle, in physics means there are no other particles below it.
Right. Well, I would say elemental is the sort of the word for that, or fundamental. But I'm saying all this vocabulary gets a little messy because people keep using even the word particle. Well, I know. I'm just saying though, even the word particle gets dangerous, right? I'm just saying that it's language. You have to be really careful. I wouldn't call it
right. But I'm asking the conceptual question is simple,
yes,
and that is,
yes.
Everything is made out of one particle.
Reductively, yes.
And nothing, that particle itself is not made up of anything else.
Right. Yeah, a little bit moving the speed of light, having a color, and nothing gets simpler than that. That's the simplest it gets.
Okay. All right. Yeah, that's very different from ours. Ours it follows Dr. Borchert's philosophies, and that is infinite. That is, you can't have a partless part. That is, you can't have an ultimate. Because at the end, what happens is if you have an ultimate particle, you're going to have to assign it certain properties. It's going to have to organize itself without any other help, and that's okay. I mean, that's one of the ways people have models.
Well, that's what, like I said, is taken care of in my model, in the sense that all of the complexity is easily understood because of this difference between going straight through something and taking a right turn. And once you take 4 right turns, you create a circle. Right, so you can sort of imagine that that's a trap. That's like a speed trap for quanta. So once you get them forced to move those 4 right turns, okay, then you take energy and you convert it into matter.
Mm-hmm. Okay, well that's interesting model. There's numbers of models out there that have, like, they do claim the ultimate particle, And I sort of see what you're saying. So
Yeah, no,
okay, cool.
I have, like I said, I liked part of your theory. It's just that when, you know, I just think polarization is so much a part of exactly why there are these different interactions. And like I said, it fits my magnetism model. It's just, you have to have polarization to be able to make magnetism work. But anyway,
sure.
yeah, I did notice you said something about the Tesla people, and I did write that down just as an interesting subject, because it does seem a weird phenomenon that people are so fanatical about Tesla. And he wasn't a remarkable scientist in any way. I mean, the body of his whole work was pretty bad in some respects. I mean, he had a simple assignment, you know, in terms of he was paid $3 million to go make a telegraph. I mean, you know, wireless telegraph. And instead, he kept trying to send tons of energy across space. You know, he kept trying to do the telegraph with lightning bolts. And, you know, this whole obsession with free energy, you know, and I guess that's very appealing to people. They want perpetual motion. I mean, that was always an interesting thing as a kid. I mean, did you ever think about trying to invent a perpetual motion machine? I mean, I did when I was a kid, but, you know, it's just, these are now adults, and you're saying, why do they really think you can have free energy? I mean, you can have energy that's easy to access, you know what I'm saying, like nuclear or something. It doesn't cost very much to get a lot of it if you can do it safely. But there's no free lunch. I mean, you can't just... Yeah.
No, yeah, yeah. Well, the perpetualness of something, I think they're looking for energy in a different way. Perhaps, I mean, gravity is coming at us. We use gravity in different ways. You know, is there some way that we can go against it? That sort of thing. But really, what it comes down to is the same thing that happens with Einstein. For my documentary, Einstein Wrong, I interviewed one of the few remaining close friends of Einstein. And what you find is really the problem with science today, and especially mainstream science, is the emotional part. When you, for instance, challenge Einstein, for instance, or even Tesla, people are going to say, oh, who are you? What's your title? They ask you all these questions that have nothing to do with what your claim is. For instance, if you show Einstein wrong, which we have a myriad of things, including mass increase not happening, including light not being bent outside of coronas of suns, what happens is they then start talking about your fame, the emotional side of that. Oh, so you want to be famous. Oh, Dave, you have your channel and you want to get as many views and you want to become famous. No, that's not. We're trying to look as critical thinkers for truth. And when you look at Tesla or you look at Einstein, people want saviors. They want these people to be, you know, Einstein, when I was interviewing the man who knew Einstein, he was an electrical engineer. He called me up twice in the middle of the night to tell me, oh, do you know who the funniest man in the world was? And I said, no. He says, well, that's Groucho Marx. And I said, why? He says, well, that's Einstein said he was the funniest man. And then I get another call weeks later from the same guy saying, hey, Dave, do you know who's the most important musician in the world and the best musician? Oh, who's that? Oh, Mozart. Why is that? Well, because Einstein said. We have this emotional need for genius. We need this emotional need that some of us humans think in this way beyond our brains. I don't even know. And I think a lot of what people want is fantasy. They don't want, you know, they like the mystery of magnetism. They like the mystery of not knowing what gravity is. They like to think that somehow there's these things and there's these people with these, you know, cerebral powers, and they were doing things maybe in their garage. A lot of the people in the Tesla tech, for instance, which again, they're great people, and they're doing some pretty amazing experiments. And the problem is when you listen to their vocabulary about what they think is going on, it's very magical. It's all these terms that don't translate into the physical world.
It does have the stench of conspiracy theories also, because it comes with these claims that the government has suppressed this information, and the oil companies have stopped this knowledge from being accessible, and you know, we could have free energy and forever tires, and you know, flying cars.
Let me tell you, I am a documentary filmmaker. I hung out with the best people in the world in LA. That's where I lived. And there are several subjects that are dangerous and you have to start thinking about. One of them is one of the people who was making a documentary film about diets. For instance, I'm on an all plant-based diet. I've reversed my heart disease diet and dietary, 9 out of 10 of our diseases, our chronic diseases, come from our diet. This was proven by Bill Gates himself. But the documentary person who was just going in to try to find this started getting in deeper and deeper. One of the places he was going to go, where my wife was from Brazil, I lived in Brazil for 3 years, he was going to do some investigation until he found out those people doing investigation about the problems of raising animals and the devastation it wreaks upon our lands, including in Brazil, where 91% of the deforestation comes from wanting to raise cattle, which don't even work well there. People were dying. There are reporters and documentary filmmakers from Brazil who are disappearing. And the guy literally in his documentary says he's not going there. Now, I know also when I was doing my documentary film and I started to talk to a few people in the free energy world, I started discovering some of the same things. And I've talked with several documentary people who said they stopped doing that because of the danger. Now, I am not a person that there are forces out there that are, I'm here in Florida, 2 people who were involved in the DNC fraud case wound up floating dead onto the beach in Hollywood, Florida here. These things are not accidental. Yeah, there are powers, that is, people with money have power. And these documentary people who were going to look into these areas, some of them have pulled out because of fear of what's going to happen. Now, is it a giant conspiracy? No. What happens, though, is there's a lot of money involved.
Well, I'm just saying that if anybody has any secret knowledge that they want to give me, and I'll publish it. So I'm just saying, whatever secret knowledge people have, whatever tapes they have, whatever video, whatever evidence,
right.
If they have any evidence, I'm not afraid, so I'll publish it. Okay, I'll say it, say it, I'll post it, I'll do anything, because I'm really not afraid that Donald Trump's cronies are going to come for me or something.
Well, it's not. It's really not political. It's mostly corporations. Corporations are the ones that run all that. I mean,
sure, but look, they all have their own families, and they have their own kids, and they all have their own little subjective interest in a rational world. And I just don't, I don't buy the extent of the conspiracy theory thinking. It's just in my opinion, it's kind of unproductive, especially with the tiny bits of evidence. It's like recently, there's a discussion. I don't know whether you heard of Miles Mathis. Well, he's another dissident guy who writes a lot, and he has lots of wacky theories. He has some really good stuff about anti-Einstein, proving different things wrong about different things. But then he does something wacky, like where he says,
no, I agree. I agree.
And it's like, he starts talking about how Hawkins died 15 years ago and they replaced him with a cyborg or some other.
Right.
And you're just like, man, why don't you just throw all credibility out the window?
Right. No, I understand. To give you an example, you and I are on the same wavelength. In fact, our organization, if you look at our organization and what we are about in our mission statement and what we accept science from anybody. We accept science, good papers from anybody. You can be a creationist, you can be a UFO person, you can be a conspiracy person, but we do not accept papers that have that as a basis. If your basis is conspiracy, if your basis is politics, if your basis is religion, we do not allow papers on that. If you're talking about physics, we don't care what your motivations are. Well, we have one guy who's got probably the best force equations on the planet who put, his name's Dr. Bill Lucas, and he's a creationist and he does things in that area. But when he deals with us and he writes papers, they are completely scholarly. There's nothing about creationism at all. He has unified the 4 forces in mathematics, and it's a brilliant work, and I let everybody know about it. But on the other hand, he also talks about how old the earth is. I am not here to tell anybody anything about that. I'm not here to criticize, but I do say that our organization doesn't accept those. We accept people. In fact, we get along quite well. Atheists get along with creationists, get along with Buddhists, we get along with people from all kinds of backgrounds. And we have people with PhDs from MIT in physics, and we have people who are literally, you've got one guy with an ether theory who's an ex-judge, Supreme Court justice in Canada. So we don't care about what your titles are, but we care about your science. And I agree. For instance, there's a guy named Dr. Gerald Pollack, and he discovered the fourth phase of water, which is actually H3O2. And water has this form, and this is one of the reasons you slip on ice. This is one of the reasons water has a sort of almost like a layer on top of it, which things can set up on. It actually, we know for a fact it forms into these hexagons. But then he goes further and says this type of water will cure all these diseases. Now, submit a paper to us, we wouldn't accept that paper. But when he gives talks about the physics of the fourth state of water, which does exist, we will accept it. So yes, I am totally on board with you. Some of the dissidents themselves, get in their own way.
Yeah, I mean, it's like, look, he believed in angels. Newton had a lot of wacky beliefs, but he didn't write books about it. And that's the difference. He didn't publish in his Protea or whatever it was, a bunch of his, fantasy beliefs about what was controlling the universe. He just said what he could prove, or demonstrate with evidence. And that's really where it's like this whole idea of having real evidence versus, just a lot of people have a lot of jargon. They'll use, there's another guy called Ken Wheeler. I don't know whether you've heard of him, but he's the angry photographer. It's on YouTube. It's the Aura something or other. But anyway, he just uses all this incredibly strangled language, hyperborealoids and, instead of saying a reflection, he says a refraction, compressions and refractions. And, it's just all this.
Yeah. Well, what's in. Yeah, you're right. You're absolutely right. And what's one of the problems with our group is to not be thrown into that model. I mean, our people have graduated from some of the best colleges on the planet. We are people who don't believe in conspiracies and UFOs, most of us. But what happens is you get thrown into those groups, and they said, oh yeah, there's those crazy guys. Yet when you go and look at these things, we have people who are not crazy at all. We have one guy who's from NASA. He couldn't publish because when he worked for NASA in their laser imaging, and he noticed that light was not bending outside of coronas. General relativity says that light will bend because of mass. It has nothing to do with coronas, just of a very dense mass, like the sun. But if you get outside the sun, it should still be bending. He shows that it isn't bending. It only bends in the corona, meaning, yeah, light bends in water, light bends in the corona of suns because there's mass. Coronas have mass in it. They're not empty space. It's not
bending, it's just scatter. But that's a whole different argument. But the only thing I would argue with his statement was that he was using some of Maxwell's equations as gravity equations and using Gauss's law, and the inverse square law doesn't. I don't think you can do that. Because you're changing.
No. But let's take a step up from that. You're getting into the details, and that you're totally right to be able to say those things, and I understand what you're saying. Let's step up a step from that, though. Here's a NASA scientist saying we don't have evidence of general relativity.
Right. That's what I wish.
I mean,
that's where you say language. So let me real quick. That's where you were talking about how people say something. And it's like I was hoping he would just say it a little better, where he would say, look, we don't have any imaging evidence of lensing, okay, in the sense that with our own sun. The only thing we've been able to lens is radio waves or some other disturbance. And because you're not imaging it, you're not going to be able to detect lensing. You're not going to be able to tell the difference between lensing and scatter. So if there's no image, the diffraction that gets you a shorter route for a radio wave is exactly the same as the lensing route would be, but the point is you're not lensing an image, so therefore you can't verify it. Well, no, they don't have any image.
He does see stars in different positions when it goes through the corona.
I've never found
through the corona.
No.
That's what he's seeing. What he doesn't see is the same effect when you're outside the corona. So
they're stars, though. I don't think that's when he was giving his presentation at Thunderbolts, right? That's the one I saw. The argument was he was talking about radiation, but he wasn't necessarily talking about photographic images. So he wasn't talking about starlight. He was talking about radiation.
Right, but according to the standard model, light and radiation are the same thing. It's just different frequencies.
I'm just saying, though, but the image is what makes gravitational lensing significant, in that you'll keep the status of the outside edges will be the same. The right and left edges, the top and bottom, are still in the same order. Where with scatter, that doesn't happen.
Right. I guess I know what you're saying, but because I've known him for a long time. I've met him personally.
I'm just saying language again.
But I think what you're saying is not all true according to what I know from him. But what you're saying about what you think is happening, of course, I understand. So, but again, if you step back a step from that and just say, here's a guy from NASA saying, look, folks, gravity, the effect of gravity does not affect directly the electromagnetic waves. This throws completely out general relativity, but no one listens to it.
Yeah, I like to throw out electromagnetic waves. So I think they're just as bad a concept. They're just made up. There's no evidence that a photon has ever been moved by electricity or magnetism. So why would a photon be in the category of called electromagnetic wave when it can't be affected by either one of those forces?
No, that's great. But again, we can't even get past the public past the other things.
Exactly. But yeah, so those were two themes I wanted to talk to you about, were just the idea of what we could do together, or what I can help you with, or you help me with, or what collectively the dissident community needs to do. And I was thinking the first thing they need to do is have an open forum of some kind, where all of these subjects can be openly discussed, because none of them can be discussed in any kind of pop. I've gone to forums and I get deleted. You just can't you can't make an argument that isn't in the confines of what they've established as real science. And as soon as they label you pseudoscience, they say, oh, we've been there and done that. You're all crazy. We won't talk to you. And so there can't be any conversation with, them. They just, because their groups won't allow us in. So we have to make a group that's strong enough or interesting enough that they'll come to us. Because we need to have the real argument with them, with the scientists who believe in the Einstein theory. They're the ones we have to defeat.
Well, you can't defeat them, because one of the first things in 1992 when I met Dr. Riccardo Carrazzani, who showed special relativity wrong very clearly, mathematically and physically, I read as many books on scientific paradigm shifts as I can, and there was never a case ever where you had the mainstream changing in their own lifetime. It doesn't happen.
Einstein.
No. What happened was the people who were at his in the older generation at his all died not believing it, even though it's wrong. Now we know it's wrong, but that generation didn't believe it. It took another generation to get that. Give you another example of it's the string theory, which is totally ludicrous. In fact, I remember when I was living in California, they had a public day at Caltech, and the original string theory people were being interviewed. And I've looked. I have a very good friend who's a high up editor at the LA Times. I can't find this, but the LA Times wrote it way back in the 90s about how the guy from string theory was totally appalled how everyone took that and now thinks that's real. It was completely invented, and with time, people will make it into something real. So we have both problems going on, where we have really good stuff that's not going to be accepted until that generation dies out, or crazy stuff that's even crazier that they hold upon, and that becomes as if it's real. It went from totally ridiculous to something real, where you have now Neil deGrasse Tyson saying that General Newton's right to the point, then Einstein's filled in and got it right, and it fails in the center of black holes, and therefore string theory is going to fill it in. That's how bad we are. We're just completely in such a bad place. But we're not going to convince them ever. They're going to die.
Saying, you can say that. I don't have any. There's no prohibition in any of my understanding of how the world works. It's much more arbitrary than that. Like I said, if it wasn't for Eddington, Einstein may have gone through life quite as an obscure scientist with kind of a wacky theory. Okay, so it's these arbitrary little events that take place that make all the difference, and you get to prove one thing and establish yourself as having credibility, right? Einstein was made half credible by doing the Mercury thing, and then he was made entirely infallible when Eddington proved the light bending. That was just two, you know, he hit 2 home runs, and that's all you needed. You're a hero forever.
And it has a lot to do with mass media. He was the first. He was when mass media was coming about, and he was the first. And it was hair. It was hair.
New York Times headline is what did it. Okay, I mean, you know, that was the slippery slope of his fame, and you know, the rest. And like I said, he lamented in the end that he might have been on the wrong track, which I appreciate his humility towards the end of his life, because he was basically saying, I don't like where any of this is going, and maybe I was wrong about the whole damn thing.
Sure.
You know, it's interesting. But I'm saying, though, that I think this can be done through a conflict, you know, creating some sort of obligation for them to prove something rather than keep declaring something. They keep declaring what exists. They say these neutrinos exist. They say this exists. They say that exists. And we don't get any rational data how it exists. So every lensing image, they just say, yes, it's the gravity and it bends because there's arcs over seconds and this kind of bullshit. But if you challenge them and say, well, if there's a lens that's 3 light years across over there, that means everything behind it is going to be in a different position, because you can't make the lens go away. Okay, once you create a gravity lens, it's a gravity lens. It means it's big. You know, and so I'm just saying there's consequences to all that stuff. And so in my opinion, those arguments need to be made in some forum where these scientists have to account for what they're saying. You know, they make
there's the thing that I've learned, and I've been in this over 25 years, is that you're not going to get them accountable. No matter what you give them, they're not going to budge on it. What we need to do, in my opinion, is to organize and get ourselves out there. The reason I started my channel, and it was only in May where I started, and it's, you know, it's slowly building up. It's pretty small, but it's got a steady and slow growth, is because no one is out there challenging openly. People will not say it, and unfortunately, those people who do challenge, I know you subscribe. I subscribe to your channel as well. You can tell pretty quickly if a person's really one of those off their rockers, a little wacky kind of person. And what they're seeing is a person like myself who's totally feet on the ground. I don't believe in magic. You can't say things, even charge. You have to give a reason physically for those things. So what happens is, what we need to do is give what I call the majority, in my opinion, the majority of us who think all this theoretical physics is mumbo jumbo. If you ask most engineers, they just laugh at it. You know, they just laugh at this idea that they're infinite points with infinite mass. They laugh at Brahms, the idea that there's parallel universes that touch each other and it triggers big bangs. Even the Big Bang, people say, well, what if the universe was the size of a pea? What's around it? Not universe? So what happens is, we don't even have people like yourself. Now we have myself. We need to have voices out there, just like in the progressive movement here in the United States.
Right.
We now have YouTube people out there, and there's a bunch of them. So I'm trying to get more and more of us, people that I really see are really great scientists, who are not wacko, who aren't out there saying that, you know, not only do they have a theory, but it can cure every disease, that kind of thing. And just build up a community, because those people, I have a lot of people, and I only have not even 140 subscribers, but I have them from all around the world say, Dave, keep it up. Most of us think this way. You just give a voice to it. So the first thing is just to give a voice to it. The other thing that I'm having to do is, people want to know about this. I point them to the database, they get lost. So right now we're creating a new database. I'm creating it is to give people an introduction. Here are the really great people, scientists, and they don't include these people who are a little bit, you know, suspect, that have these, you know, start talking with this language.
That's what I'm getting to, though, is that, you know, that's the good part of what you're doing, is this idea of compiling and having a source, you know, and once there is a good source, I'm just saying that source will be its own engine of popularity, in the sense that the challenges we make will eventually have to be answered by the professors and the rest of them, because they'll just be open questions sitting out there where we present the evidence on one side and they present nothing. So they're going to be
well, what's going to happen? You're right.
So I just want to add one more thing.
Sure.
But the only change I'd make to your approach is that there should be a segregation of the stuff where here's my alternative theory and the stuff that is this is why they are wrong. So those two arguments have to be completely separate from each other, because if you don't make them separate, then you end up with all the conflicts and the infighting, you know, because then it's our competing theories we're arguing instead of arguing the one goal, which is knock the giant Goliath down. We got to get Goliath down before any of us can claim the territory.
Right. Understood. You hit a nail on the head that I only sort of got in my brain, at least marketing wise, because I think you've been in the marketing side of this more than I have. And on our new website, we have three things. We have, number one, what I call flaws. And these flaws are like anomalies or problems, whatever you want to call them. I call them flaws because they get people's attention more than just saying problems with mainstream, you know. So it's a marketing thing. So we literally have, I'm building objects in WordPress, special posts for these things that they have things you have to fill in. So we have one for flaws. The next one we have is for the scientists themselves. Who are the scientists today that are going to be the Copernicuses of tomorrow? And what are they doing? The third one are, okay, you've knocked them down. Here are the people doing it. And they are very credible. I mean, you know, some of, like I said, PhDs from MIT. Here, the third one is, what are they coming up with new? For instance, you should, without a doubt, write up, I will encourage you here in public, you need to write your stuff down, your theory down, publish it, proceedings, even look into coming to our conference. I'm a particle person, you and I are particle people, there are particle models out there. You should definitely be writing this down, putting it in format. I do have it on my
website. I do have that started.
Right, but what you need to publish in this are proceedings right here. You need to put it, because it's a proceedings. Listen, we have the proceedings. What can we bring to you guys? Is right here is you have.
Well, yeah, maybe you'll give me a discount on the membership, and I'll go for it.
No, I'll give it to you for free.
Well, I'm just saying, I'm a terribly cheap person, so yeah, that was the only reason.
I'll get you. Look, because it's more important. We have people who we are doing it for free because they're retired gentlemen or women, and they don't have the funds. But see, this is a publication. It has a format. It looks like any publication from any society.
Exactly. That's why I find it what you're doing very encouraging, because I think that's the foundation.
So I am putting you and your followers on notice today. Putting you and your followers notice today. You will be publishing in our next proceedings. I will give it to you free, whatever you need, but you will be there because you have some very good ideas, and those need to be put into a formal way so that when a student and they're doing a report on something and they're looking, well, what other ideas are there from light and particles and atoms and stuff, they can look up your stuff as well as anyone else in a formal place. We have also, the other thing I'd like to tell you, which is one of the things you hit upon, which we are doing, is we have a thing called philosophy.org. I'm a computer programmer. To put in a full wiki on a server is very hard. You don't just do an install. It's a lot of work. I've already done that. We have 13,000 pieces that I've actually transferred from our database into the wiki. In there, the Wikipedia, which keeps putting things out. For example, the expansion tectonics, and they call it Earth expanding Earth. I put in the top person on the planet, Dr. James Maxlow, who's got a doctoral in geology. I put his name just listed as one of the people in that area, even though it's on Wikipedia.
I know.
They removed it. How could they remove the number one guy?
When I put an augmentation to Lesage gravity, you know, and just included a brief statement and a link, right, they deleted all the other links to justify deleting mine. So there was 8 links there. They took all the dissidents and wiped them all out, okay, just to kill me.
Yeah, that's ridiculous.
That's how malicious they are. That's how malicious they are. They'll harm other people to get to you. You know, they'll sit there and take away other people's, you know, the resource, the availability of the information. Right. But yes, the fact that Wikipedia doesn't do alternative, they should always have a link section for alternative links. I mean, the idea that they refuse to do that just makes it, in my opinion, just grotesquely biased.
Right. And what we have, and let me explain, we have this in our Wikipedia. So if your listeners go to wiki.naturalphilosophy.org, here's the reason this happens. Wikipedia is the ultimate in consensus. That's what it is. It lives on consensus. Its job is to say, this is what we think, right or wrong. So if you can't put in alternatives there, because that's what an encyclopedia is supposed to be, the up-to-the-date, most accepted knowledge for something. This is what gravity is. This is what light is. This is what blah, blah, blah. So it, by nature, because it's open, will fail. It will not allow alternatives in it. And so that's why we have our Wikipedia. And that's why if you are one of your listeners or yourself want to take one of their pages, we can copy it because it's out there. We can copy it. We'll just start adding to it the way it should be. That's what we want to do. That's what our objective with wiki.naturalphilosophy. And not why natural philosophy, because that's the word that they used to use before this terrible modern word of physics came in.
I just don't like the word. I just don't like the word philosophy being used. It's a personal prejudice, just because philosophy deals with things that you can't prove, in my opinion, and science should deal with things you can prove.
Well, you can never really prove anything. What you can do is you can have a theory that
provide evidence for it. That's all I'm saying.
Right.
Beyond logical evidence, there is no evidence for certain.
But in reality, philosophy is very important in science. It really is. So I understand what you're saying, and I understand the bent on which you don't like philosophy, and I agree with that. But as to the part of scientific philosophy, which is what we're talking about, so natural philosophy is really could be relabeled as scientific philosophy, and that's the difference. And it's just that we use that because that was what we called. Where science before it went off on a rail.
Yeah. Like I said, this is just probably just a personal prejudice, but it's just I like the word science or truth much better than I like the word philosophy.
Right, but if one of the things, if you do get involved more with our group, we have some great philosophers. In fact, Glenn Borkard, The Scientific Worldview, is, in my opinion, the best scientific philosophical book written in the last 400 years. So, I mean, that's my opinion, of course, but philosophy, I didn't really think it was important too until I started reading people and I go, oh, yeah.
No, don't get me wrong. I think philosophy is more important than, technical science, actually, because the moral philosophies are the most important philosophies there are. But I'm just saying, I don't like the combination of the two mental disciplines because they are based on different kinds of deduction, different kinds of validation through different kinds of facts.
But that's what I'm saying. I think right. I think the difference is when we say natural philosophy, we're talking about scientific philosophy. So I think that's the way you should think about it. The way I look, I'm going to have to get going here pretty soon. Was there a few other things you wanted to talk about before we wrapped up?
Well, they're all in the same vein of subject, in the sense of creating the idea of a forum, the idea of even creating a publication, an online science journal, that the dissidents publish, where they'll include other conventional scientific theories. But I'm just saying, where there's a more rigorous editorial evaluation, in the sense that
that's what we have.
Where you have the editors actually vote instead of not publishing, because obviously on the internet now, publishing is free, essentially, right? I mean, it's not like you have limited space in the magazine, so you can publish an infinite number, this theoretically, of papers every month. But the only ones that would be ranked based on how the editors saw it. So if 10 editors thought it was junk, it'd have a rating based on what the editors thought of this material, whether it was of a high standard, of a low standard. And so that you would get published, but you would just be stuck with an editor ranking and the editors would let you know why they gave you their ranking. So it'd be that simple. You get at least a paragraph from the editor saying, this is why I rated this low, is because I don't understand what you mean by hyperboloid, and how that it creates attraction or something like that. So I'm just saying that there has to be, we have to try to move the ball field. I guess what I'm trying to say is we have to try to move the ball field to our ground. We have to move
Right.
it to our mountain. We can't let them own the high ground, because if they own
Right.
the high ground, we're always going to get shot. We're going to get constantly shot down. We got to take the high ground.
Right. No, exactly. And I agree with you. And I like the idea of having this available. In fact, that gets back to it. We have an immense amount of papers that are absolutely interesting. So if a person came along, for instance, and didn't study why special relativity was wrong, we've got over 200 papers, but you can't easily find them. What we need to do is make these things accessible. And I like your idea of publishing and then having people, have an editorial board that works with that and says, okay, these are accepted there, and having those things accepted and put in a place that becomes the repository, right? And the other thing is too, I think the last thing I'd like to say, and I did a talk on this many years ago, and it's gotten a lot of views actually in our group, and that is consensus in science. One of the things that we get wrong in physics and cosmology is that there can be only one model, and that model is right. And I think that's where also we go wrong. And I think one of the things, like every other discipline, we have all these computer languages, we have human language, we have different philosophies, different religions, no religion. We, some reason, think that the universe has what I call these God equations. And so once we find E equals mc squared, every civilization in the universe will find that. And that's not true. Even our mathematics system is a mathematical system we've come up with, that there are different mathematical systems. So we have to...
Two-ness and four-ness will be the same everywhere. So I don't think you ever break that one.
Well, no, there's certain things. So, again, those are scientific philosophies. I agree with you. But I mean, as to a model for something, we can have several of those, and they can work better than others, just like we can have several rocket ships in the way they come back to Earth.
I'm still saying that, in my opinion, we've advanced enough as a human race, and we have enough data to draw pretty hard conclusions and real conclusions. I'm just saying the fact that we've gotten the wrong answers is our failure, not the failure of the amount of information we have. We have a volume of information.
That's a discussion we can have later, because in my opinion, this is a sort of a arrogant type of thing that we ourselves put upon it, which is there is only one model, there's only one place.
I think it's a simple universe. Yeah, I think it gets dirt simple. The smaller you get, the farther you go down, the turtles get really dumb. They get really simple.
But that's in your universe. In ours, it's not that way. So it's again, the most important thing is those things should be able to live together. One of the things that we show in our group, and I have in this new website, in fact, maybe what we can do is we can talk about, what we can do. Like you said, I think we can use our talking together, and I can have you on my show, which is a lot smaller of subscription than yours. But what we can do is start talking about exactly that. How do we get our voices out? What do we do?
That's what I'm saying. I love talking physics. I love talking the details. But sure. I think, a more important conversation is this whole organization thing, and why it works and why it doesn't work, and how we can make it work. Because
absolutely,
I think we both see that as that's the path.
Paramount.
That's the road.
Exactly.
That's the direction. Okay, we might not have the path, but at least we know that's the direction of success.
Right. And our organization, and I think you see in it correctly so, our organization is trying to do that and has been doing it for over 20 years. So what can we do more? How can we do more of it? Let's talk great. I really appreciate your invitation, and we have a lot in common. Like I said, let's go and do this again. I also want to encourage you. I'm going to get on your case for getting a formal paper in about your own ideas and your own theory, so we can get it written down. One of the things is, you got to remember, we have to have that in a form that when someone comes, they can read it in a scientific way, the way they see everything else. Web pages a lot of times have this tendency to be sort of just out there, and but when you put it into a paper, people who are students are going to read this, and they may be excited and start working. We're along with you.
It's pretty much just text and a few figures. So my web page is it's not doing anything fancy. It's just describing.
Right, but when you are forced to write a paper, you're forced to give your assumptions. You're forced to put them down. It really does help. It really does help people who read it to understand it more, because then when you write that paper, if we read it as editors and say, wait a minute, you're not clear on this, we're going to give you feedback on that until we think, okay, it's complete. Because one of the things about web pages, oftentimes they meander and they're not complete amongst themselves, and there's questions people have that aren't answered.
Yeah, well, that's another subject we could argue for a while. Communication skills.
Yeah.
Or how best to communicate an idea. But anyway, yeah, I don't disagree with what you're saying. I have to.
Oh yeah, no, sure.
I have to finish my work. But anyway, it's. I'm just saying I do have substance up it. It's not like I haven't.
No, absolutely. That's why I wouldn't invite you to put in a paper in our proceedings if you didn't have substance. Believe me, I wouldn't do that. It's very. Your ideas are very interesting. I think worth putting down formally now.
Yeah, I'm just saying it's sort of formal, but I'm saying okay, I'll make it more. I'll put more F's. I'll put more F's.
That's
more
okay.
F's,
That's all
more
right.
F's. So anyway, yeah.
No problem, Gary.
Let's do it again, like tomorrow. And no, I guess I'll give you a day off. Yeah, let's keep it going and see how long before we piss each other off or something. So.
Whoops. Yeah, no, there's no problem. I'm used to it because we deal with that all the time. So I don't know if my camera went off here, but I'm sorry about that. Can you hear me still?
Yeah, I still hear you okay.
Okay. But anyways, maybe it'll come back. There you go. But I'm used to it because the people in our group have very different ideas. We have ether people, we have particle people, we have lattice people, we have different people. But one of the great things about it, we've learned to be in a room, we've learned to be in an organization, live together and work together. That's what needs to be done. That's the hardest part, because even me and you can get in an argument that will say we don't want to work with each other. That's one of the things we have to do, just like tolerating other people's philosophies, sexualities, politics, way of life, whatever. These things have to be worked out, and we have worked them out in our group.
Yeah,
get along.
To me, I get along as long as we put some subjects off. We just, you have to segregate you have to keep the focus. You know what I mean? Stay on the.
No, but there are going to be some people.
Yeah,
but there are going to be some people who stand up and talk with you and say something that you totally disagree with scientifically. But if we are still open and none of us are the owners of the truth, then we have to be tolerable and let that person say it. Say, okay.
Right. No, it's not politics, so it should be a safer thing, is all I'm saying. So it's not like it's dangerous as a political conversation.
People get really riled up. We had several fights.
Yeah,
we had several almost physical fights in our last conference because people get so emotional about it.
Yeah, you got to be. That's all I'm saying. I just want to be careful enough to know that there's some stuff we probably got to be a little careful. That's all. Because I don't want to. If you start wearing, if I start seeing you and I see Donald Trump or something, it'd be really hard for me to have a friendly conversation, if you get my drift.
Yeah, but we have people that, I'm not religious. We have people who are very religious, but we get along. My dad and I have very different religious beliefs and political beliefs, but we're writing a book together, and scientifically, we have some of the greatest times ever together. Yeah. So that's one of the things I think we can.
I said that in the profile. You're a lot more accepting than I am. I'm just giving you a fair warning that I'm not nearly as
Don't worry. I'm a peacemaker. I think you got great ideas.
I only throw words, so that's, you can always know that, right? So I only throw words. So yeah, that's the worst I'll ever do to somebody is throw a word at them. So if they can handle that, then we got no problem. As long as you can handle a word, then we got no problem.
Yeah, no problem. Okay. Listen, Gary, I'm going to get going here. I've got my real job. I got to get back to work here.
Yep.
So
Okay.
I work in supercomputers to earn my living, and I'm past my lunchtime.
Yeah, I understand. All right. Till next time, then. Good talk.
Okay. Take care. Thank you so much.
Yeah. All right. Bye. All right. So that was pretty good. Write my paper. I just don't understand. What do you want? Detailing a physical diagram of the entire function of the universe isn't that simple, Even though it's checkers, still hard to describe checkers on the 17th level, 17th level checkers or something. So anyway, let's see if there's any comments worth commenting too. There's quite a few of them here. Greetings. No, we don't do greetings. Chrome is the most popular. No, that's crap comment. I love it. I don't know what that is. In conclusion, Einstein is a fag. No, that's not very useful. Um, let's see. If you make it hard, the philosophy is wrong. Got to agree, Gary. I don't know what that. Oh, the probability is probably wrong. Yeah, I don't know what that means exactly, but we get gear effect explanations, but science doesn't look the cause. I don't like that too much. Does this guy with glasses have a YouTube channel? Yeah. I'll put it in the link. I just didn't have time to do anything because everything was not working. Great hangout, thanks. Okay, you're welcome. Yes, write your paper. Okay, David Hissner, D. Hilster. I don't know why I call him Hissner. Freudian slip. And yes, he has a YouTube account. Okay, yeah, so we did that part. All right, so anyway, yes, I'm done. Yeah, I could just do some more rambling closing music or something. Tesla was a kook, a crazy, crazy pigeon feeding kook. Yes, he was very nice to animals, but he was a lunatic. Crazy, crazy, crazy. Homo, sort of, mostly. Anyway, yeah, so, yeah, that's all you get for gratuitous entertainment value. So, at least this worked, so see if it works next time, and such, and so forth and whatnot. So, till next time.